Hi, Mr. Greenwood here, and we're talking about multi-view sketching. So we're moving on from isometrics and looking at how we can create sketches that we could utilize for blueprints. So what we're going to be showing in these different views are how we can capture dimensions of a three-dimensional object into a flat view, and we see at least two of those, and we'll show where those dimensions overlap in different views. We're trying to create a basic contour or shape of the object. So for deeper, we'll get into some of the line conventions in our next screen recording. And when combined, we can use these to communicate blueprints with designers, manufacturers, students, all of the above. So here's an example of a multi-view sketch, and this multi-view sketch is showing our isometric view of our chair in our upper right hand corner, which we just got done practicing, and now we're looking at our flat views of our orthographic projections. And with this, we should have 6 sides, just like a rolling dice when we're playing Yahtzee, and we should be able to see 6 different sides. This one we're only showing 4, so we left out the bottom view and the backside view, but we are showing front, top, right side, and left side. And so with these different views, essentially what we're going to see for the most part is we're going to see a front view, and then we're going to see a right side view, and then our top view, and then our ISO view. And this is how our piece of paper is really going to be divided up as far as a quadrant. So visually, this is what you should think is going to happen with your blueprints for your main pieces that we're working on. So in these views, we have width, height, and depth that we can see. So width, we're going to think side to side, height, top to bottom, and then depth is what you might also call length, but we're thinking of front to back dimensions on this one. So let's see where we actually see these. So here's our isometric view, and we've already labeled front, top, and right view. And if we take our piece and we rotate it down from the top to the front, there's our orientation, and then there's what we see from the right side. Pretty basic shape, and so we see basically a rectangle in 2 different views, and we just also include an extra line when we see the face come to an edge. So that line right here and that line right here. And so moving forward, what we have is with all of these different dimensions, we see them in at least 2 of the views that we show in front and right side, and with our front and top view for width. We would also see it in our left side view as well, but we want to at least include it in 2 views. So our heights, they line up, so orientating and lining these up together is great. And this is what we should practice. And then that way it's able for us to keep our contours in line with each other. So when I mentioned the faces change and they actually come to an edge, that's this point right here or right here, and that line is shown in the top view. Depth is seen. This one, if they were to space out this right side view a little closer, we would draw this 45-degree angle line from this point here, but they went ahead and spaced it out. But this is just showing you in blue that depth is here from the top and bottom of the view, of the top view, comes over, it hits a reflection mirror line, comes back down, and then that should be the same size there. So orthographic projection, it's a technique used to create these multi-view drawings. And we have to think of this as an imaginary line of sight when we're looking at things perpendicular to the plane. So what we mean with all those fancy words is our line of sight is right here for our front view. And then for a plane of projection or a picture plane, we're just thinking of that surface. Oftentimes we draw in Rhino and how we're having everything on that flat surface or that project plane. And so the surface onto which that 2-dimensional view of 3-dimensional object is projected and created is what we're trying to capture on our multi-view. So orthographic projection is where we're at. So when we're looking at this projection plane and we're thinking of our line of sight, which is perpendicular 90 degrees to it, it's good to identify some points that we can go ahead and connect some lines to. So we have our points labeled here, 1, 2, 3, 4, 5. And what we would be doing is just connecting those lines to that as far as bringing an outward plane. And then also when it comes to drawing it, we're going to go ahead and just connect these dots as well. So this is showing you how the projection plane could come out away from the object, kind of the glass box method. And then the anchor points, if you want to think of them as that. And then when we connected these, they would then be turned into object lines shown in green right there. And that's what we would portray in our front view. So here's a different example with the projection planes. So this is all 6 views of this piece here, and we have our front view. So let's just identify front view is coming from that line of sight there. And so from that front view, we can see this little line here. We can see this, 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 and this. And those are all shown in our front view right here with just object lines. If we rotate and we move over to our right side view, we almost see the exact same thing, just mirrored with all object lines, no hidden lines. Top view, pretty self-explanatory, no hidden lines. So this is the best orientation of this piece because these front view, right view, top views don't show any hidden lines, and so we want the object lines to be shown if we can orientate the piece that way. So for this example, we could get away with just showing this right here, and then we wouldn't have to include the rear, left, or bottom views unless they do add clarifying points that we can't capture in the front, right, or top view. So the hardest thing is selecting the best view to start with in the front view. So I recommend starting with your front view when you're looking at orthographic projections, and just make sure you keep these things in mind. You're trying to satisfy all 5 things. Sometimes you have to jeopardize one of them. So what's the most natural position? Shows the best characteristics of the shape or product. Longest dimensions, fewest hidden lines like we looked at the last sample, and most stable and natural, which is kind of a repeat of 1. So in the rest of this PowerPoint, there's some examples of the orthographic view selection. So best front view, looks pretty good. And then we're going to start looking at some advanced things when we get into symmetrical parts and eliminating one other viewpoint. So encourage you to use construction lines, follow up with your object lines and points, and you should be able to recreate an object simply like this. So get started with your bounding box, measure out the same equal distance away from each view. Your 45-degree line can help as well, and then focus on putting your views in these blue shaded regions. And everything will come over. So this line here with this arrow is showing where it would be visible in the front view and the right side view. And then this line here is seen in the front view and in the top view because we see the edge if we were to reorientate it. And then we continue on with getting our basic shape. And following all our lines that transfer over. Once we have all our object lines, then it's best practice to move on to your hidden lines. Once you have all your hidden lines, then you'd be moving on to your center lines. Here's one example. This one's a more organic shape, so there's a lot more construction lines that are showing for the angles of movement for this mechanism. So these views potentially could be rearranged. And the tricky thing is the front view is not always the front of the product. So the front of the car is not always the best front view. The actual side of the car shows the dimensions and a little bit more of the contours. So the side of the car would probably be the better front view. This question is just having you look at the different views, or I should say the top view of this. And so the top view is all the same because it's just the bounding box. Thanks for watching.